Okay, yeah, we were just talking about that, so maybe we should have that on camera. I mean, we got to look good with this tie on camera. So even if I didn't get any input, this is the one I was going to wear anyway. So, whew, whew. So we would have picked the right one anyway. Okay, so one of the things I want you to think about is there only one way to get ethyl benzene? Now that's a hard question. Now that is an extremely hard question. Okay, so there's actually two ways that you could prepare ethyl benzene. Okay, so first of all, this isn't one of them where it's going to be a two-step process. Sometimes when I'm doing them, I forget that you have to go through two phases. So in this case, the way we like to approach this is we know. Now, why can't I do that all the time?
Except for the one corner.
This one?
The left side is super good.
You do a pretty good job of drawing yours. I don't know, or not. Who draws the best hexagons? I can't argue with that if you learn from the best. Yeah. Yep. So the only thing we need to add is, if this is ethyl benzene, somewhere on there we got to put what? Okay. So then, of course, there's two different ways you can do that. Some people, they're just comfortable with this. Okay. That's fine. And other people may choose to do this. And of course, that's fine. Okay. But I think until you really get a good understanding, this, I think, is how you should do that. I'm not going to say you have to do it that way, but that's just a recommendation. Okay, so if that's our end product, how are we going to start that here? Okay, we'll give you this much. See, I can do that twice in a row. I don't have any excuses or reasons why. Just don't or can't. Well, not can't, but for some reason I don't get the same product. Okay. So would you presume, okay, well, if that's an ethyl group, let's just do that. Why are you right? Well, there's a lot of things that we're supposed to do that we just don't for some reason. I'm certainly a good example of that we need to clean the house. And I'll look around. Really? It's not that bad. Wrong answer, guys. Okay? Wrong answer. Okay, so with that, you already alluded to what you wanted to. Let me start over. You already made reference to what you had to do because you said something about a halogen. Okay, so on your chart, of course, any alkyl group, that variable is what? I sure hope that's what you said. Okay, then any halogen is what? Okay, so notice we don't have that here. We don't even really have an R group because that's a stable alkane. Okay, so how do we change this to an RX, do you think? First of all, we got too many hydrogens, we'll give you that. Okay, so we'll change that to a 5, and then, so we got our R variable now, and then what's X? Okay, and for some reason, I would probably do that all the time too, just because I think chlorobenzene is probably just a widely used industrial product, probably more so than all the other aromatic compounds. So now we've got our R and our X. Then to get to there, our final step is what? Is it acid, is it heat, or is it a metal catalyst? Okay, then I just always keep using what we have here. So iron, nickel, cobalt, it just says any metal catalyst. I just usually go between aluminum and nickel because I would be led to believe that those are the most common ones. Now that reaction is going to proceed. Okay? And on your paper, it is possible that you might see something like this, and that is intentionally gone. So why would that be significant? Right, but why? What's true? What is the difference between what you would see here? I suppose we should probably put all of these on here. What's the difference between these two compounds?
Bonds are really strong.
Yeah, these bonds are just way too strong not to react. And some of you had interpreted that number 5 correct. When you're adding a halogen to this, that double bond breaks really easy, and both of those halogens will attach and replace those hydrogens. Okay, so that's one way. There is a perhaps less common way that you can get from here to here, and it is on your chart. It's just the reason that it's perhaps a little more tricky is because typically when we talk about putting alkyl groups on there, probably toluene is the most common reaction that there's going to be. It just is, okay? So if we wanted to start this over, okay, and in this case, and I had such a hard time struggling reading that clock upside down. So I'm going to try to get it right this time. So rather than yesterday we said it was 9 o'clock. Now I got that right because I just remember the conversation. So rather than being at 9 o'clock, let's look at, what would you say, 11? I got it wrong again. 1 o'clock. Dang it. Oh, I was just seeing if you're paying attention. See how that goes. So what do you notice at 1 o'clock?
You go to attach a halogen and you use an acid catalyst.
Okay. So then what happens in that reaction, okay? I've only had 2 cups of coffee, I swear. I have not drank that much coffee. Okay. Let's try this again. Okay. So then the most common example again that we could, or the simplest, not the most common one, we could say is also this. Okay. So how would we get, according to 1 o'clock, okay, what is it that we're going to add to get to that? Does it say something like alkene on there, something like that?
Yeah, there's no E on
There's no E on that because I think a text box got put on there, and sometimes I think sometimes when you make that, it cuts it off for some reason. I don't know why. So with that, okay, if we're going to do that, okay, here's our alkene, of course, and then it just says acid catalyst, right? I'm presuming. I don't know if it says specifically whether it's sulfuric acid or I don't think nitric acid would do that, just because when you're adding nitric acid to a lot of things, you might end up with something on here that you don't want. Now, does that say that that's going to happen? That I couldn't tell you for certain. But what you do have on that chart is accurate, okay? So now what we see happening, the acid catalyst will cause this to attach on this ring. Then, last thing we'll do, anything that you add beyond this, okay? Anything. Doesn't matter what. Where is something going to attach on here? If that was to keep going. Is there one or two answers? If we really wanted to be picky, we could say there's three answers, depending upon which direction you're going to go, okay? Because if we're going to do an ortho, whatever it is we're adding on here, it could be this side or it could be that side, okay? But then the para position, there's only one answer, and that's straight across, okay? Because sometimes one of the things, that's as far as I'm going to go with that, because you do have that as a tool. So with that, there's going to be word problems that are going to say state or show or illustrate different ways to create these compounds, and that's why you have that chart. Okay. Any questions on your paper before I shut this off and give you the rest of the time?
On question 14,
Okay.
it's, you have phenol and ethane. Right, yeah, because it's just single bonded, so.
Right. Okay. So typically what we would say that happens with that, okay, we're going to look at our key, and then once we see that what's going to happen, okay, just like this one here, we're going to change that to okay, that was what, 14 you say?
14, yeah.
Okay, so then what happens is, of course, I know where that phenol, where that OH is located, but I'm just going to do this just to be a butthead. So we got to do that every now and then. Well, that's every day. Nah, I don't know. But now that that's on there, okay, this will disassociate, okay, and then with your catalyst then that you have down there, it's going to cause it to go in two spots because of the director that OH is. That's correct. Mm-hmm. That's also correct.
And then we leave the C2H6 as is.
Just change it to that instead. Saying change C2H6 to what you see here. Okay. As you can tell, that is not my handwriting on there. It sounds like I'm passing the buck, and that's probably true. Another step? No. Nope. I didn't realize that was on there. I didn't, number 13. So we actually did that just now. So, but that's okay. So, is there anything else to add? Because one of the things I like to say is I'm busy. I know you're busy too. So, going once, going twice.
How do you do number 16?
Dang it!
Propyl chloride.
Propyl chloride, number 16. I didn't quite say sold in time. Okay.
Just a benzene plus propyl chloride. With
Okay, so you're going to answer your own question because what is this called right here? It is. You're not seeing the forest for because we're looking at some of these higher order thinking aspects and combining a whole lot of steps. If we go back one chapter, okay, propyl chloride means how many carbons are you going to have? Okay. Okay. How many hydrogens do you think you would have? If it's propane, it would be how many? If it was propane, it would be how many?
10.
If it was propane, it would be how many?
8.
It would be 8, okay? But we don't have propane. It doesn't say add propane. It says add propyl chloride. So that must mean there's a specific number of hydrogens, and then there's our chlorine. So from propane, which is C3H8, what's a derivative of that? There's actually two of them. Of course, a propyl group and an isopropyl group, but it doesn't say that. So if it says propyl chloride, here is our propyl group with 3 carbons, not 8 hydrogens, but rather how many?
6.
But rather how many? 7. Okay. Then, but that's why we go through it. Okay. This is difficult material. The reason it is because it's a lot of stuff that you haven't learned yet, and we're applying materials that we had done last chapter into here, some of these higher order thinking, so aspects. So this is propyl chloride. What would this one be called then? It's only 2 carbons. Ethyl chloride. That's probably why it's so tricky. It's something that comes up from last chapter. Okay. Now, going once, going twice. I got the gavel down that time.
There you go.
All right, we'll catch up to you next time.